Today, I will show you guys my Calculus 1 Exam 2, and this test is mainly on differentiation. I will have the file in the description for you guys to try the questions first before you guys draw the solution. And we have a total of 20 questions. The first 10 questions are multiple choice, and the last 10 questions that you have to show your work. And now let's go ahead and just get started. For the first one, we are given this y, and we will have to compute dy for x is equal to 2 and dx is equal to that. So let's go ahead and just do the derivative. dy is just the derivative of this times dx. So let's use the power rule first. Put a 5 to the front and then minus 1. So we have 5 times 1 plus x to the third power raised to the fourth power, and then use the chain rule. So multiply by the derivative inside, and that's 3x squared. Then we will also have to multiply by dx, because usually we have the dy over dx, right? But again, this is the differential, so we multiply the dx right here. Now we can just throw in all the given information. 5 plus x to the third power, and x is 2. So we have that. Then times 3x, and the x is 2 squared, and the dx is 0.0005. Use a calculator, you will end up with 196.83. Nothing wrong with this because the answer is E. Yeah, the first question is none of the above. All right. Second one, we are going to differentiate this. So go ahead and I'll do our derivative. I will use f prime for the notation. The derivative of ln is 1 over whatever we have inside, which we have the sine. So we have 1 over sine x. And use the chain rule, multiply by the derivative right here, which is cosine x. And then minus another ln, so that's 1 over, here we have cosine x. And use the chain rule, the derivative of cosine x is negative sine x. If you divide and say cosine x over sine x, that's cotangent x, but you see we don't have any cotangent x. What we do for the last one, but you know this and that will give you tangent, there's no other part, right? So we will actually have to combine the fractions and see if we can get the answer that way. First fraction is cosine x over sine x. Minus times this minus, so we have a plus, and then we have sine x over cosine x. Alright, let's get our common denominator. For this one, we will need to have cosine x and cosine x. For the second one, we will need to multiply the bottom and the top by sine x. That way, they both have the same denominator. Alright, then we see the denominator is just sine x times cosine x, and then here we have cosine squared x plus here we have sine squared x. And notice cosine squared x plus sine squared x is nicely equal to 1. So this is just 1 over sine x times cosine x. Still not it, but you know 1 over sine x is cosecant x, and 1 over cosine x is secant x. That said, the answer is A, cosecant x times secant x. Okay, next, number 3, we have a Pikachu question. Pikachu is trying to use Newton's method to find the roots of this equation. Which of the following is a bad initial condition? AKA, the Newton's method won't work with this initial guess. So what exactly do we do though? Well, let me recall the formula for the Newton's method. The main thing is that we have xn plus 1. This is equal to xn minus the function at the previous x value, which is the xn. And then we divide it by f prime of xn. And as you can see, we have the denominator, this right here. We have to make sure the derivative here is not equal to 0. Otherwise, we'll just divide it by 0. So that said, we just have to look at this equation and make sure that the derivative is not equal to 0 there, because if it is, you will have a horizontal tangent line, and if you do the Newton symmetry, it won't work. So our function is, make sure that we have the right-hand side equal to 0, which it is. So the function is just x to the 5th power minus 5x plus 3. Take the derivative real quick, we get 5x to the 4th power minus 5. Set this equal to 0 to find a bad number. And as you can see, x1 is equal to 1 because 1 will make this 0. But if you would like to do the work, 5x to the 4th equals 5. Divide both sides by 5. x4 is equal to 1, meaning x for the real numbers will be plus or minus 1. But of course, here is the 1. So 1 is not going to work. You can use 0.9 and hope for the best and all that. Okay. Number 4, another derivative question. Taking the derivative of inverse tangent. So let me remind you guys on the side real quick. When we differentiate inverse tangent, this right here is 1 over 1 plus x squared. All right? And now we have this inside, so be careful. Here we go. This is equal to 1 over 1 plus, let me put a parentheses, square. The inside is that square root, so go ahead and enter the square root, e to the x minus 1, and then we multiply by the derivative of the inside. Right here, let me remind you guys, the derivative of the square root function is 1 over 2 square root of x. Here we multiply by 1 over 2 times the square root of that inside, which is e to the x minus 1. Are we done? No. Chain rule one more time. The derivative of e to the x minus 1 is e to the x. Whew. And now we are all done. Now the rest is just simplification. Square root cancel. So here we have 1 plus e to the x minus 1. 1 and 1 cancel. So the first fraction is pretty much just 1 over e. Next one, this is pretty much it. Nothing can be simplified here. But notice we have this e to the x and this e to the x. They can cancel each other. So cross them out. So in fact, at the end, we just end up with 1 over 2 square root of e to the x minus 1. And that is C. Number 5. Which of the following is true? Go ahead and think about this question first because this is one of my favorites. So make sure you think about it before you watch the solution. Done? All right. The answer is D. D is correct. Now let's make the corrections. The derivative of x to the third power, it's not 3x. It's meant to be 3x squared, right? It's 3x squared. What's the derivative of 3 to the x? No, it's not this. This is 3 to the x times ln 3. And what's the derivative of 3 to the third power? This is the same as asking the derivative of 27, and the derivative of 27 is just a number, so right, the derivative of a number is just 0. And now, why is this correct? Because we can look at the derivative of 1 over x as x to the negative 3, and we can put the power to the front, and then minus 1, and we get negative 3 x to the negative 4. This thing can go to the denominator, so we have negative 3 over x to the 4th power. That's why this is correct. Number 6. Notice for this equation, the y is not isolated. We have sine y and y times sine of x. So we will be using implicit differentiation. And let me just write this down right here. X times sine y minus y times sine x equals 1. And I would like to just put down ddx, which means that we will take the derivative with respect to x. Implicit differentiation in action. For the first part though, notice that we have a product. so we have to use the product rule. Keep the first function, which is x, times the derivative of the second function. Derivative of sine is cosine, and the y stays the same, but we multiply by the derivative of y, which is dy dx. Then we add the second function, which is sine y, times the derivative of the first. Derivative of x is just 1, so done. Next, we will have to use the product rule for this derivative. This is the minus though, so we have a minus. Product rule again, keep the y times the derivative of sine x, which is cosine x. And then, well, here we have a subtraction, so if you would like, you can put a parentheses, and then inside will be adding, or you can just say minus minus, depending on how you want to do it. But I will put a parentheses like this. So we have the second function, which is sine x, and we will have to multiply by the derivative of the first, and the derivative of y is dy dx. And this right here is equal to the derivative of 1, which is 0. All right, now focus on where the dy dx is, which is this right here, dy dx, and we also have a dy dx. We want to put it on one side and then the other stuff on the other, and isolate the dy dx. That will be the answer. So here we have x cosine y dy dx. This part does not have the dy dx, so I'm going to put that to the right hand side, and that will be minus sine y. Then, if we distribute this negative, you see that this right here is negative y cosine x. That does not have the dy dx, so I'll also put this term to the right hand side. So that will be plus y cosine x. And then when we distribute this to that, we will get a negative sine x dy dx. All right, now we can factor out the dy dx, and usually like that to put the dy dx at the end. So I'll just put down x times cosine y minus sine x times dy dx equals this, but let me just change the order to be y times cosine x minus sine y, because that will match the solution better later on. And finally, we just have to divide this on both sides. So, ladies and gentlemen, dy dx equals y cosine x minus sine y over x cosine y minus sine x. I love how this question has like a nice symmetry, because you see you have the y, you have the x, and you have the x, you have the y. Yeah, but anyway though, the answer is A. Done. Number 7, oh my god, it looks like we have a fraction. It's also a trig function. What's 1 over secant? Don't worry too much. 1 over secant is just cosine x. So this question is only asking you what's the derivative of cosine x, which is just, oops, negative sine x. So the answer is C. Done. So definitely don't use the quotient rule, nothing else, right? 1 over secant x is just cosine x. Okay, number 8. We are going to find the second derivative of e to the x squared. So here we go. This is our function, and here is my first derivative. I'm going to just, keep e to the whatever, right? Derivative e to the whatever is just e to the whatever first. And then when you multiply, use the chain rule, we have the 2x here. So that's the first derivative. Then second derivative, we look at the first derivative and take the derivative. So we keep the first function, which is 2x, and we multiply by the derivative of the second, which will be e to the x squared times the x squared right here. So perhaps I'll just put that down right here. Derivative of x squared is 2x. And then we add the second function, which is e to the x squared times the derivative of the first, which is just a 2. clean things up, 2x times 2x is 4x squared. And then we have e to the x squared plus 2e to the x squared. And that's it, because we don't have to factor out anything. That's what the choice A is. So, done. All right, number 9, we are going to find the linearization. And this is just like a fancier name for the equation of the tangent line. Because when we have a curve, when we draw a tangent line to the curve at some specific x value, we are pretty much looking at the curve as a line if you narrow it down to like a small part. So that's our linearization. And there's a nice formula for it. I will tell you guys the formula. The formula is pretty much the same as the slope of a line when you are given the point and also the slope. L of x is the linearization. You just do f prime of a. A is pi in this case, all right? That's the slope, and we multiply by x minus a, and then we add the value of the function at a. Really, it's just the point slope form of the line. Check this out. Y minus y1 equals m times x minus x1, yeah? And then we add the y1 to both sides. Y equals m times x minus x1 plus y1. x1 is the a. And then y1 is when you plug in a into the function, and to get the slope is the derivative of the function at a. So really, it's just the same as the point slope form of the line. That said, let's just go ahead and plug into the formula. Well, we also need the derivative, though. Be careful. So right here, the derivative of sine of 2x. Derivative sign is cosine, and the 2x stays, but make sure you use the chain rule. So multiply by that 2. So now let's just go ahead and go to work. Let me perhaps do everything here. F prime of a, which is pi. This right here is 2 times cosine of 2 pi. Okay, cosine of 2 pi is cosine of 0 is just 1. And then 1 times 2 is just 2. So all in all, this is 2. And let's also do f of pi. And that's sine of 2 times pi. And that's equal to 0. This is the original. Yeah. And that's pretty much it. So L of x equals 2. And then we have x minus a, which is pi here. And f of a is 0. That's pretty much it. And then we can just multiply this out. We get 2x minus 2 pi. Done. Answer C. Number 10, we will find the second derivative of the inverse cosine function. So let me just write this down like this. When we have d2 over dx2, it means that we have to differentiate the first derivative. Differentiating the derivative, which is differentiating inverse cosine of x like this. Do this inside out. We take the derivative. Well, when we differentiate inverse cosine, this is a multiple choice question, so we can just write down the answer, which is negative 1 over square root of 1 minus x squared. Now, differentiate this. What do we do? You don't need to use the quotient rule. All you have to do is rewrite this first. So on the bottom, notice that we have that square root here. We can write that as the negative 1/2 power. So we have this negative right here. Sorry. We have this negative right here. And then we can just say that raised to the negative 1/2 power. And the inside is 1 minus x squared. From here, we use the power rule. Bring that power to the front. And let's see what we get. Negative times negative, we get positive 1/2. Be careful with the sign. And then we have the 1 minus x squared. Negative 1/2 minus 1 is negative 3/2. And don't forget the chain rule. multiply by the derivative of 1 minus x squared, which is negative 2x. Now, these two, that two cancel, and this x will be on the top over this term has the negative exponent, so we'll just write that on the bottom, which is 1 minus x squared over, 1 minus x squared raised to the 3 over 2 power. But unfortunately, none of the answer is like this. But don't worry, because the over 2 power is the same as the square root. And don't forget that there's a negative, so it's negative x like this. So finally, we have negative x over, I will put down the square root, and we have parentheses 1 minus x squared raised to the 3rd power, and that's the answer, which is answer choice C. Done. Alright, show work questions. Number 11. We are going to prove the quotient formula, right, the quotient rule for the derivative by using logarithmic differentiation, and this is how you need to do it. So we can just say that, or I should technically write it this, let f and g be functions of x. And I'm not going to be too picky in terms of the details. So right here, I will just say, assume both of them are positive, so that when you take the natural log of f or natural log of g, it will work. So I'll just assume that they are nice. All right, so we can say let y be equal to f over g, and then of course follow the steps. We will be using logarithmic differentiation, meaning we take ln both sides first. This tells us ln y will be ln f over g, that's just ln f minus ln g. As you can see, when we do this, we don't have to deal with quotient anymore. Now we will take the derivative with respect to x. And keep in mind though, f and g are functions of x, and f is equal to f over g, so y is also a function of x. So y is equal to f over g, so y is also a function of x. Take the derivative of ln y, we get 1 over y times dy dx. The derivative of y with respect to x, we need that dy dx. Next, we have ln f. The derivative of that is 1 over f. And you can write down df dx, but you know the quotient rule formula, we'll be using f prime. Minus the derivative of ln g is 1 over g, and again, g is a function of x, so we multiply by g prime. Good, now we are going to multiply y on both sides, so that this and that cancel, and we also multiply y on both sides like this. Have a look, we get dy dx equals, what's f? What's y? Y is f over g, so let's put that down. And then for the inside, we have f prime over f minus g prime over g. Okay, that's not the formula that we know though, so what can we do? Well, for the inside, we can combine fractions. Let's go ahead and get a common denominator. So I will multiply the first one by g and g, and then the second one by f and f. So now we have dy dx equals f over g times, on the bottom is just f times g, and then we have f prime times g minus g prime times f. That's pretty much it. But notice one little thing though. This f and that f can cancel because you can multiply that out, and then you see that g times g is g squared, and this explains why we will have to square the denominator. So dy dx, y is meant to be f over g, so when we do dy dx, that's the derivative of f over g. That's equal to, well, as I like to say it, before we forget, let's square the denominator, and let's rewrite the order in the usual form. We keep the bottom function and times the derivative of the top, and then minus the top function, right, times the derivative of the bottom. But if you keep the derivatives in this form, it's okay too, of course. And that will be it. Number 12. All right, here we are going to be using the Newton's method, and specifically we know x1 is equal to 2, and we are going to find the third approximation, which is x3. And we have this equation, which is ln x is equal to x. ln x is equal to negative x. How do we do it? Keep in mind, in order for us to use Newton's method, the equation has to be equal to 0 on one side. So that said, we are looking at the equation ln x plus x equals 0 after we add the x on both sides. So we can define f of x to be ln x plus x. And of course, you know it, we need the derivative. So f prime of x is 1 over x plus 1. And now the matter is just go ahead and use a calculator and then do the work. So I will write this down for you guys. x1 is given to be 2. And remember the formula, xn plus 1, meaning the next x value equals the previous x value minus the f value at that previous x value. So f of xn over f prime of xn. That's Newton's method. So x2 equals, we will start with 2, and then minus f of 2 over f prime of 2. And of course, you can just say this is 2 minus f of 2, you put 2 into this, which is ln 2 plus 2 over f prime of 2. So you put 2 in here. So 1 over 2 plus 1. And we will just have to use a calculator to compute that real quick. And that's the 2 minus parentheses ln 2 plus 2 divided by 1 over 2 plus 1. And let me just make sure that I got the numbers right. Or maybe you can use a calculator and work it out on the way too to double check my answer. I have 0.2046. I round it to the fourth decimal place, right? It's technically 5 and then 6, but then I'll just round it up. All right, x3. This right here will be equal to 0.2046 and then minus f of 0.2046 over f prime of 0.2046. So this means 0.2046 minus ln of, right, you put this into the original function, 0.2046 and then plus x, which is 0.2046 over 1 over 0.2046 plus 1. And when you use a calculator, make sure you put parentheses on the bottom. All right, I should have mentioned that right here. So that's that. And now let me just do that for you guys real quick as well. 0.2046 minus parentheses ln of 0.2046 and then plus 0.2046 and then divided by 1 over 0.2046 and then plus 1. And I end up the answer to be approximately 0.4393. So that will be the answer. And again, just stop right here because we just want x3. Okay, next one. Another implicit differentiation question, the one it's not isolated, right? So here, let me write down the equation one more time. we have x squared plus xy plus y to the fourth power equals 10. And implicit differentiation in action. Alright, the derivative of x squared, we get 2x. Next we add. Here we have x times y, so we have to use the product rule. The derivative of x is, well, we keep the function x times the derivative of y, which is dy dx. Then we add the second function, which is y, times the derivative of the first. Derivative of x is 1. Next, the derivative of y to the fourth power is 4y to the third power. Remember y, the derivative of that is dy dx. And that's equal to the derivative of 10, which is 0. Now we just have to get the dy dx by itself. This and that can go to the other side. This and that, we can factor out the dy dx. So let me highlight this for you guys. This and that, we keep it here. And I will just write parentheses x plus 4y to the third power times dy dx equals 2x to the other side becomes negative 2x, and then y times 1 to the other side is just minus y. Lastly, divide this on both sides. Dy dx equals negative 2x minus y over x plus 4y to the third power, and we are done. Yay. Number 14, we'll take the second derivative of this thing. Alright, again, let me write it down like this. So I like to write it like ddx, and then ddx, and then ln of 1 plus x to the third power. So parentheses. And this is the reason why you only see d2 and then dx2, because you have the dx twice on the bottom like that. Okay, we will take the derivative. Look at this first. The derivative of ln is 1 over whatever this is, which is 1 plus x to the third power. But don't forget the chain rule. So multiply by the derivative of 1 plus x to the third power, and that's 3x squared. So let me just put that on the top. And then we can use the quotient rule, or you can use implicit differentiation with logarithm like what we did earlier, but use the quotient rule. It's much better. I'm going to square the denominator before I forget. And we will keep the bottom function, which is 1 plus x to the third power, and we multiply by the derivative of the top. The derivative of the top is 6x. Then minus the top function, which is 3x squared, and we multiply by the derivative of the bottom. Derivative of 1 plus x to the third power is 3x squared. So now we can just distribute the 6x inside and see if there's anything that we can simplify. So that's equal to 6x plus 6x to the fourth power minus, and we can also multiply two things together, 9x to the fourth power over, you don't need to multiply out the bottom, just keep it in the power form like this. So that's what we have, and then we can combine like terms. On the top, we get 6x. Here we have the 6x to the fourth minus 9x to the fourth, so that's minus 3x to the fourth over the bottom is 1 plus x to the third power, and then squared, and then we are done. So that is number 14. Alright, number 15, another differential equation. So here's the deal. Y is 1 over square root of x, but let's write it as x to the negative 1/2 power, so that we can just use the power rule. Bring this to the front and then minus 1. So dy dx is just going to be negative 1 over 2, and then we have x. Negative 1/2 minus 1, that will give us negative 3 over 2. And remember, we want to get the differential dy. So you can just multiply the dx on both sides. So this right here just tells us that dy equals -1/2. And then perhaps also put this down on the bottom. Doesn't really matter that much though. Let me not do that because we'll be using a calculator anyway. So 1/2 and then x to the -3/2 power and dx. And now let's just plug in numbers. -1/2 and then x is equal to 9 goes here, raised to the -3/2 power, and then dx is 0.2, so multiply by 0.2. And then let's just go ahead and use a calculator for this. We get -1/2 times 9 raised to the -3/2, and then multiply by 0.2. So I get, well, the answer right here on the calculator is approximately 0.0037037 and then 0.37 so on. But according to the direction, rounded to the third decimal place, which is right here. So that will be 0.004. Okay, number 16, we are given a quadratic equation and we are going to find the third derivative. I will tell you the answer is equal to 0, but I'll show you guys the work. F prime of x. Differentiating this, a, b, c are constants, so we get 2ax plus b. That's all. Do this again, f double prime of x, we get 2a, right? Because this is x to the first power, and then again, like this part, the b will just give you 0 for that. One more, the third derivative, a is a constant, 2 times a is still a constant, 0. So this right here is just equal to 0. Number 17. Okay, this looks hard, but it's actually not. If we do algebra first, then the calculus step is going to be much easier. So here's the deal. We are going to rewrite f of x as 1 over x squared plus this over that. Square root of x is the same as x to the 1/2 power, and then over x to the second. Then we can rewrite both terms in the power form. 1 over x squared, we can write it as x to the -2nd power plus, okay, x to the 1/2 divided by x squared. What do we do? That is just 1/2 minus 2, right? That's -3/2. So that's the new power, x to the -3/2 power. You just subtract the powers. Then you can just simply do the power rule. Okay, so f prime of x equals, we get -2 times x to the -3, and for the other one, we will have -3/2, x to the -3/2 minus 1, which is -2/2. So we get -5/2. And you can just write the answer down like this. I don't mind. I don't mind. Yeah. Or if you want, you can simplify it. That's totally okay. You can write it as possibly like this: -2 over x to the third power minus 3/2 x to the +5/2. And if you really want to, you can multiply this by 2 and 2. Multiply this by x to the 1/2 and x to the 1/2. And if you have this, then we'll have the same denominator, which is 2x to the third power, right? 5/2 plus 1/2 is 6/2, so that's why it's x to the third power. And then this right here is -4 minus 3. And if you want to simplify x to the 1/2, you can write that as square root of x. So I'll just say, or this. So one way or the other, doesn't matter. All right, number 8, we are going to show that the derivative of cosecant x. Number 18, derivative of cosecant x is negative cosecant x times cotangent x. So you can do it two ways. I will do it this way. I think it's cooler this way. This right here equals, take the derivative of 1 over sine x. You can use the quotient rule, or you can write this as taking the derivative of sine x and then raised to the negative 1 power. Do not write this as sine with a negative 1x like this though, because this means the inverse, which is not what we are talking about here. Once you have this, you can then use the power rule, bring the negative 1 to the front and minus 1. So we have negative. Inside is still sine x. Negative 1 is minus 2. Then multiply by the derivative of inside. Derivative of sine x is cosine x. Alright, now we can write this as negative cosine x on the top over sine x to the negative 2 power. So we can write it like this, sine square x. But I want to end up with this, so I will bring 2 here. We can write this as negative cosine x over sine x times sine x. Yeah. And then we see that if we look at 1 over sine x here, so that might not be 100% clear. If we look at 1 over sine x right here, we have the negative, and 1 over sine x is precisely cosecant x. And then cosine x over sine x is cotangent x. That said, we are done. Number 19, we are going to find the equation of the tangent line, which is just a linearization, all right? So it depends on how you want to approach it. You can use the L of x formula that I showed you guys earlier, or you can do it the slightly more traditional way. Let's go ahead and find the point first. We know x is equal to 0. Y is square root of 1 plus x squared, which is 1 plus 0 squared, which is just 1. So the point is 0, 1. Next, we need the slope. The slope is the derivative. So we need f prime of x. Take the derivative of the square root. We get 1 over 2 times the square root of 1 plus x squared. Then use the chain rule. The derivative of x squared is 2x. This and that cancel. So we are just going to get this as x over square root of 1 plus x squared. We want the slope when x is 0, so it's f prime of 0. And that's actually just 0 over square root of 1 plus 0 squared, which is really just 0. So you see, this is really the same as the point slope form. Y minus y1 equals, m, which is the slope. This is the m, times x minus x1. And the point right here is x1, y1. So all in all, we have y minus y1 is 1. And that's equal to m, which is 0 here, times x minus x1. x1 is 0. So many zeros. Wow. But this right here is just y minus 1 is equal to 0. And in fact, we have a horizontal tangent line. Y is equal to 1. So that will be the answer. Finally, we are going to take the derivative of x to the x power. And this is the classic way to do it. We can say let y equal to x to the x power. Then we do implicit differentiation after we take the natural log on both sides. So this right here becomes ln y. And then for the right hand side, we can put the power to the front. So we have x times ln x. Then implicit differentiation. Derivative of ln y is 1 over y times dy dx. Here is x times ln x. So we use the product rule. First function times the derivative of the second, which is 1 over x, plus the second function times the derivative of the first, and that'll give us 1. And then we will just multiply y on both sides, so that this and that can cancel. And ladies and gentlemen, dy dx equals y is x to the x power, and then we multiply that by x times 1 over x is just 1, plus ln x times 1 is just ln x. That said, this is it. dy dx equals x to the x power times 1 plus ln x. And that's it. That's the second test.